在录在录。
开始。左右的是哪个？这是上下的，左右的是哪个？
你先把它固定好。
应该还有一个调左右，左右这个，左右的可以动一下。
主要它再高一点。
啊？上面是，下面是拉伸，再高一点，再高一点。你看到黑板的字，你看到黑板的字。
Looks like a lot of work. Because I still don't plan to get PA, PE, but if for some reason things change, so you can
Okay. Who's my spot last?
I didn't get a spot, so I can do PDF.
你看这话你怎么那个？你怎么操控这个镜头？你怎么操控镜头？你说这吗？还有后面？你这前面，你这
是再往下一点。主要他没把 PPT 给你。
差不多吧，这样应该看得到。这里看不清楚，但是放大应该看得到，就是在视频。这个视频上应该是没问题，应该一块黑板就够了，能录一块黑板就行。
它应该是PowerPoint。
就当你坐哪坐这吗？
都行。
你这块你怎么那个？你要把它放桌上，把这手短一点放桌上。
手怎么样？啊？是要调那个？
不是，我就把这脚手短一点放在桌上。
但我就怕人家的头。
你的脚你再放高一点。就视角大概就是那么高。
我都行。
要不然的话，你在这边你很难调。你视角把脚收紧。
这样。算了，上课，下次。
那这次就行。就说他只用 PPT 吧，就
看他怎么样。
那我们就做这个。
I don't have my notes, so like I'm not. Is this intensive?
Sorry.
Yeah, so I realized that it's kind of.
因为你看这个，在那边你看到屏幕，你把这个弯点就看到屏幕。
I assume the Java has.
用了弯这样的弯。
I don't doubt you. I just thought.
那看不到。这样，那差不多，你可以在这边看。能这样吗？不行。
等一下。 下次近一点去第一排，
对，就是没有。
他就自然刚
Well, I would say
现在你也可以放这一排。
Still unconscious.
放这个。可以看到，
可能他这个屏幕小，放到电脑上就干净了。
对啊，这个屏幕太小了，看不清。如果它分辨率对，它分辨率够的话，在电脑上看应该没问题。
就这样吧。我做闹去了，我做闹去了。
你坐这边。
That's the group. Oh, that's what you mean by like criticalness, as in that 120. Okay, that was not clear to me. Criticalness to me would be the lowest you could possibly get. I mean, you have to 1 to 6 for
1 and 6 to the 4.
yeah.
That's just to get the next type. One. But that's the same thing. Like 25 or above.
Okay, let us start. So welcome everyone to our machine learning class in this semester. First class, scheduled in the evening. Sounds a little weird time. So, so this is a mixture. Excuse me. Do you have any questions? Oh, okay. So this is a mixture of senior undergrad class and the graduate class. CS 5350 and CS 6360 machine learning. So I'm the instructor. My name is Shandian Zhe, and I'm a faculty member at School of Computing. So I specialize in machine learning, more on probabilistic perspective. So here are a bunch of research topics I focus on, and they're all sub-areas of machine learning. And I also apply machine learning techniques to address many interesting applications of problems such as recommendation in Amazon, Netflix, predicting friendship links, identify community structures from large social networks, and using neural networks to solve partial differential equations. That's very interesting in physics simulations. And analyze like human brains activities, using identify those abnormal activities to predict possible brain diseases. And also using machine learning techniques to associate the genetic variances and some human illnesses. So I'm very excited to be to have a chance to introduce you the machine learning world. Like 10 years ago, machine learning has already been hot in academia. By that time, nobody, no machine learning researchers can imagine what machine learning is nowadays. So nowadays, machine learning is really changing the world. So maybe you have heard a lot of buzzwords like artificial intelligence. But I can tell you the popularization of artificial intelligence, or the third wave of artificial intelligence, should be attributed to machine learning. And machine learning is a force, is the power of artificial intelligence. So I'm very excited. I've been working in this area for 10 years. And so here's the outline we're gonna cover in the first two lectures. So first, we'll give a brief definition about machine learning. What is machine learning? So can you give me a not too rigorous but formal definition, right? With that concept in mind, and we try to learn one and another machine learning algorithm, try to implement your own machine learning algorithm, try to build up your own machine learning libraries and test your libraries with real data sets and see how it works and see its power. And then we'll go through in detail the course syllabus. We'll talk about the course requirements. How do we set out what's the goal? What's the goal of learning this course? After you're taking this class, what change you're expected to have, right? And to finish, to meet our goal, what kind of assignments, what kind of tasks we should finish, and how are they reflected in your final grade? This is very important for most of you. And then at the end of this lecture, if we still have time, we'll start to review some basic knowledge. So somebody may think like machine learning, they feel like machine learning is very cool, but it depends, because it is actually an elegant combination of theory and practice. That means you need to be familiar with basic mathematics, including probability, linear algebra, matrix derivatives, and etc. And also you need to know how to program. You do not need to be a program master, but you need to implement those machine learning algorithms. We're not just doing solving problems on paper. We need to solve the problems by hand. Okay, so let us talk about the first question. what is machine learning? So can anybody give me a hint, like, according to your understanding, or even according to your intuition, what is machine learning? You can give whatever definition you want.
You use certain type of algorithms to basically learn a probability distribution on a data set, and then we kind of use that to basically guess guess an output given on some like data that you haven't seen before.
Your answer is kind of more specific to the probabilistic perspective. While if I teach another course like probabilistic learning, I will use your answer as a definition. But can anybody provide another viewpoint?
It's when a machine has the ability to get better at a task over time.
Yeah, that sounds a great idea. So your answer actually points out an important feature of the learning behaviors. It is not only applies to machines, it only applies to humans. So how should we say we learn something? How should we say we learn something? From some experience, we should improve our capability in doing some particular type of task. That's the essence of learning. Any other suggestions?
Maybe one of the big things is that, like, we as humans look at things and don't necessarily identify them consistently in a way that you can give rules to a machine that it will always follow. And those rules can change over time, but that hopefully they change in a better way than you or I would change.
Yeah, I get a sense that actually you're telling about a procedure to evolve to be better and better. Yeah, so it's kind of, am I right? Yeah, so it's kind of consistent with the previous answer, right? You have to iteratively improve your skill in doing something. So to illustrate the process of machine learning, so let us play a simple game and to experience the learning procedure, to think about, to imagine a learning procedure. So this game is called Badger's game. So in 20 years ago, 25 years ago, the attendees of the conference on computational learning theory. So this conference called Rift Code is still the top conference in theoretical machine learning. So the attendees of this year's conference, when they arrive at the conference hotel, they receive their badges with some labels. The labels are either pluses or minuses. Of course, those labels are not just randomly generated. There is a rules of mapping between the names of the attendees and the labels. And there's only one person, this guy, who knew the underlying function that generates the label. So the attendees are assigned a task that they're required to look at or collect as many badges and labels as possible, and then try to work out the unknown function. This is called Badger's game. So assume we are some attendee and we collected 6 badges, 6 examples with names and the labels. So can anybody think or suggest what is the underlying function will be? Let us just think for like 10 seconds.
We need more data, won't we? this enough data for us to determine the function that would?
Yeah, that's a very good question regarding the sample complexity. But right now, let us just put aside. I just give you these 6 vectors with names and labels, and I want you to learn the unknown function that generates the labels. So what kind of functions come out in your mind? The length of the name can be more specific. So what particular?
So if there are more than 13 characters or 13 or more characters, there's a possibility.
Yeah, we can count the number of letters, right? So
Yeah.
we have 2 positive labels. The names are, the first name is Peter Bartlett. It's
The first one has 13.
the first has already had 13.
Yeah. The length of the first is even or odd.
So at least from my point of view, I thought this mapped example still has a very long name, right? This 12.
With a dash it would be 13, but without the dash it would be 12.
Without dash would be 12. Okay. That sounds
Plus.
But if we had like,
Yeah.
10 more samples, then we'd be more sure.
yeah, of course. Yeah, that's one solution. Okay. So you have another.
Yeah, can we just say if your first name starts with D or
Yeah, of course. That's very good. That's very good. This is another. Why? This we only have 6 examples. So all of those 6 examples, you can come out many perfect functions or rules that can generate those labels correctly. But I don't know the underlying function either. I don't know. But I have the data, the full data. It's not only 6 names. It has 200 names. So if you're interested, we can upload the full data sets, like 200 names, and you can use your eyes to go through those names and find out some functions, and maybe the simple rules will work. Right? So this process, that is the game we just played, is a typical learning procedure. So basically, we have 3 steps. So first, we collect a set of examples. In the game we just played, we collected 6 examples. Although it's quite tiny, it's not enough. That's just for fun. And then, from those examples, we'll try to extract some patterns, find some relationships, right? Mapping relationships. And the third step, which we haven't done, is that once you're sure about the function you learn from the data, when I give you another name, which is not in our examples, what kind of labels can you use your learned functions to predict? So this is typically 3 steps: training, example, collection, and training or learning, and third, prediction. These 3 steps consist of a typical learning process. So now, if we replace players by machine, it's actually machine learning procedure. So before I'll give the more formal or rigorous definition about machine learning, so we can briefly take a look and see how machine learning is powerful. So AlphaGo, has anybody heard of AlphaGo? Okay, good. I thought everyone has heard of it. So has anybody played the Go game? Maybe you can teach me sometime. I don't know Go game. I know I should be familiar with Go game because the Go game originates from China. I was born in China. I don't know Go game. I know how to play chess. But I can tell you, Go game is way more complex than chess. The reason is that the number of states in Go game. That means if two players sit at the table and play around, right? Every time you place a white chess and you place a black chess, and you do it alternatively until finish. The number of such kind of ways to finish one round is way more than the total number of atoms in the universe. That means you cannot use some mechanic search method. Like you build up a supercomputer, right? If your computer is really powerful, you enumerate all possible ways to place your chesses and to play the game and find the best way, and you will win for sure. But that's not feasible. I can tell you, maybe like 20 years ago, the Deep Blue. How many of you have heard Deep Blue? Yes. Okay, great. And Deep Blue beat the world's rank 1 player, Kasparov from Russia. Right? He's really genius. And the strategy the Deep Blue adopt to beat Kasparov is exhaustive search. Because the number of states that play in chess is not that huge. We can solve it by building up very powerful integrated circuits. And the IBM researchers actually build a very powerful chip, and they encode the searching algorithm in the hardware. But this solution cannot succeed in playing Go. And 20 years ago, no people will believe that computer programs can win human players in Go game. But now, machine learning make it. So I can tell you, I know the ideas of AlphaGo. It's just the reinforcement learning framework. And it uses a very smart sampling algorithm called Monte Carlo tree search plus deep learning neural nets to automatically identify the status of the chess. And the AlphaGo can play the Go game with himself to improve it. And this improvement is very fast. After just like less than half year's training, it can beat the world's strongest, the strongest human players. That's incredible. But besides AlphaGo, machine learning has many applications. I just mentioned that machine learning is changing the world. It is not fake. It's not hype. It's really changing the world. And many of us have used machine learning techniques every day, but maybe you haven't realized that. For example, why do your email box look clear? Why is your email box can automatically filter out the spam emails? Machine learning. And it mainly relies on a kind of algorithm called naive Bayes, and which we will cover in this semester. It is extremely simple, but extremely effective to filter spams. Face recognition. When you give you a photo, how do you automatically tag the faces in the photo? Whenever you use digital camera, and when you open the camera, it automatically bound the faces. And the accuracy is quite high, and it's very fast. Implementing such a function depends on a machine learning algorithm called AWS, which we'll also talk about in this class. Movie suggestion and commodity recommendation. Right? Whenever you watch a video on YouTube or watch a movie in Netflix, or you buy something from Amazon or eBay, they are always trying to suggest you to watch another or buy another. Sometimes they feel, it made me feel, at least it made me feel annoyed. How do you feel? But I can tell you, those guys are really trying hard to impress you. And how do they impress you? Machine learning algorithms. And prediction of stock price. That's directly about money. If you can more accurately predict the stock price, the stock going up and going down, you will be fortunate. So actual machine learning has been used in finance area for many years, but they don't admit it's machine learning. They just said we are doing finance modeling. Handwriting recognition. A typical example of handwriting recognition is the recognition of zip code in your letters. Right? Whenever you send a letter to the post office, the very first step is to identify the zip code and to map the zip code to the target area. Your letter will be sent to. Right? So this is a very important step, and at least 95% of such kind of work are done by machine learning algorithm, and it's pretty good. And online advertisements. Whenever you search, surf on the web, when you look at some web pages, there are always some advertisements showing on the sidebars or whatever other places. Although most of the time it is annoying, but those advertisers are really trying to attract you to click more advertisements, buy more, and they hire a lot of machine learning engineers to optimize their advertising showing and selection and ranking models. Machine translation. So I don't know if you have a track, if you have tried to track the progress of machine translations. I did. Like 8 years ago, when I was a master student in my home country, in China, Google released its first machine translation service. And to me, at least the translation quality between Chinese and English is not meaningful at all. It's just a toy. To me, it's just a toy. But right now, it is really, really impressive. So I can tell you, right now, sometimes when I try to write some papers, I'm not a native speaker. If I feel difficult to express the meanings, I'll try to write down some Chinese sentence in Google Translation and see what machine translation will output, and maybe we'll copy some paragraphs or some words. So this is really impressive. And autonomous driving. So this is another thing often heard in the ear, but it's not hype. It's becoming reality. So I don't know if you have noticed that in the last August, Google has provided its first self-driving car service for public transportation. It is in Phoenix City in Arizona. So if next time you travel to the Phoenix City, I would suggest you to experience the autonomous driving. If I can travel, I would definitely try. And I will fly a helicopter here. So you can see this particular figure here. So the gesture of this helicopter is kind of odd. It's kind of weird, right? It's upside down. Right? The propellers is at the bottom. But I can tell it is flying quite stable. And it's controlled. The controller of this flight is a machine learning program. It's not human beings. So even for human flyers, it's very hard for human beings to fly a helicopter like this. The machine learning can do this. And medical study. And machine learning algorithm models are extensively used to study disease mechanism, such as Alzheimer's disease. How can we, given accumulated data from 2 decades to 3 decades, can we identify those genetic markers that correspond to Alzheimer's disease. Based on this genetic markers, and we develop effective models and algorithm for early diagnosis and preventative cares. So those are just a few examples of machine learning applications. And they are all the reality, not something we imagine, but something we hope. So now let us look at the formal definition of machine learning. The first definition of machine learning is given by Arthur Samuel. Our Professor Samuel, our pioneer in artificial intelligence, is one of the several pioneers who proposed the concept of artificial intelligence. He's also one of the earliest researchers who studied machine learning techniques in playing games, but not Go games. Go games too hard at that time. And he said, machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. That's intuitive, right? If I can ask a robot to do some specific task by giving very in detailed, explicit instructions, that's not learning. The true learning should be ability to do that automatically. And later, Herbert Simon, another pioneer, a big name in artificial intelligence, gives the definition of machine learning from the involvement. That's just as a moment ago, just the lady mentioned. What is machine learning? Learning should activate the process to improve. It says, learning denotes changes in the system that are adaptive in the sense that they enable the system to do the task more efficient, more effective next time. So meaning that after the procedure, after the process, if your capability of doing some particular task improved, then we call this process a learning process. Does this sound reasonable to everyone? Okay. And then later, Professor Michel from CMU gives a more formal definition, but basically he inherits the concept provided by Herbert Simon. He defines machine learning. He defines that a computer program is set to learn from some experience E with respect to some class of tasks T and performance measure P. If the performance of the computer program at the tasks in T measured by P improves with experience E. So now he points out several key factors involved in machine learning. So first, we need to define what kind of tasks we're learning. We're not doing general learning. Of course, general learning is the ultimate goal in artificial intelligence, but in machine learning, we focus on some specific tasks. Specific tasks can be rigorously formulated. And then we need to have a performance measure. That means the effect of your learning procedure can be measured and compared. Only based on this measure, we can try to improve our learning algorithms. And then we point out that to carry out learning, we need some experience. So what is experience? In our batch game, where does experience E correspond to?
Data?
Yeah, exactly. Right? It's actually the six values, and their labels. So in machine learning, experience E corresponds to data. We need to collect training data first.
This definition gets rid of the concept of not being explicitly programming
No, his definition tries to avoid that. Although this another the 1951 definition, the 59 definition express machine learning in another perspective, right? But why we emphasize the definition from this perspective? The reason is that it provides a way for us to improve or enhance our machine learning algorithm. How can we evaluate different machine learning algorithms? We can measure which learning algorithm can get better improvement or larger improvement according to some measure. But there is no, one unique definition about machine learning. Just give you a sense about the formal definition of machine learning, and we'll focus on this definition because this is how our machine learning research is guided. We're always trying to improve our learning algorithm. Of course, our ultimate goal is to fulfill a learning algorithm which is same as a human learning algorithm. Any other concerns about this definition?
What's the task T? Your
Task. Well,
in the learning process, what's the task?
the task depends on your applications, depends on problems. There is no specific task in this definition. For example, one task would be like predicting whether tomorrow it will be raining or snowing.
Okay.
Another task would be predicting whether government will still be closed tomorrow or not. So there are many tasks. You should define a class of tasks when we talk about machine learning. But from here, you can also have a feeling that machine learning is actually a bit different from human learning. So human learning can be even more general. I read a book, and after I don't give you some tasks, I just read a book. And after I read a book, I learned something. I can tell you I learned something. And even different people, when they read the same book, they learn different things from different perspectives. This is very different from, it's still different from human learning. Any other concerns?
When we talk about measures of performance, are we including the concept of if it wants to read gigabytes of data really quickly, allowing error tolerance, greater error tolerance, that kind of performance? Or is it all about accuracy?
This is a very good question. Actually, you can define the performance measure according to your own need. It's not, of course, many machine learning algorithms. When we measure them, we only consider their accuracy. But in many other applications, we not only consider accuracy. We also consider the speed, the efficiency, especially some industrial applications. So if I use some deep learning models, very fancy, very powerful, and I can improve the prediction accuracy by 2%. But I use a very naive algorithm, very outdated algorithm like decision trees. I can give you the result like in 1 millisecond. Which one do you choose? Decision trees, of course. So it depends. This is just a general definition.
Is performance, does that usually require the most human element in this type of scheme?
Excuse me, can you say it again?
Measuring performance, does that require the most human opinion or look at, or are there other ways to?
Okay. So first, the performance measure, of course, contains human requirements. You must encode your expectation about your learning algorithm in the performance measure so that we can compute and compare, and then later to improve according along with the direction you expect to improve. Right? But computing the measure can be automatic. It's not like whenever there's some output or prediction generated by your machine learning algorithm, you need to use your eye to look at it. It's not always like this. But sometimes you need to do that. Like, you know, the general illusory networks recently are very popular, and it is said that it can create new arcs, like new figures and new drawings. And then how do you evaluate whether this drawing is interesting or not? You need to use your eyes. But most time, you won't. Any questions? Okay. So here, we want to illustrate machine learning or explain machine learning as a process to gain the the ability to generalize. So here, give you another example. Suppose my task is to classify, to identify the dogs in pictures. So here's our training examples. And we expect that after learning from those set of pictures, when you are giving a new dog who wears a cool hat and a cool pair of sunglasses, you can still identify this dog. This is not a cat or bear, whatever. So what is learning? Learning is essentially a way to acquire generalizability. If you simply remember all of the training examples, you won't be able to identify a dog, a new dog. So why will we study machine learning? The immediate benefit is that we can build computer programs or systems with new capabilities without programming with tedious and complex and even this impossible with instructions. We can free our labor to do more creative things. The more ambitious goal is to understand the nature of human learning. Although machine learning is quite powerful, but still far from human learning. We know that we human beings can learn something only from two examples. We can generalize very well. But machine learning needs a lot of training examples. It needs big data. What's the difference between them? What kind of key factors, hidden factors that lead to the difference between machine learning capability and human learning capability?
We get better at learning.
What?
We get better at learning than robots because they're just doing one task. Like they change the way at which they learn.
So on some very specific tasks, machine learning can be sometimes be better than human beings. But in more general tasks, human beings are much better and requires less power. Like for example, if I want to recognize people's faces from image, there is some research in psychology that like baby, like in 1 year baby, when they look at faces, look at several faces, you can automatically get the ability to identify human faces. No need to train, like using ImageNet, you train like millions of images and billions of images. But right now, although with deep learning, with very cool deep learning, with TensorFlow and GPU clusters, you have to fit best machine learning algorithm like millions or even billions of images, training images to obtain the same ability. So you can see there is a huge gap between the two types of learning procedures, but we don't know what causes the gap either. And our ultimate goal, of course, is also one of the ultimate goals in artificial intelligence. We want to develop robots that can learn as human beings, but still quite far. Even in most optimistic view. And in the foreseeable future, the investment of machine learning won't stop because it can benefit our society, benefit our lives. So it can give system the ability to perform tasks which, in a situation which are never encountered to free up labor. Yeah. Especially nowadays is time for big data. We have in all kinds of jobs, works, and areas, we have accumulated a huge amount of data. Human beings are not able to process so much data. And machine learning can allow programs to interact more robustly and more responsibly with massive data which are generated every second. And also, machine learning has started to make inroads into end-user facing applications already. So we have discussed the concept of machine learning, the motivation of studying machine learning, and the power of machine learning. So let us now take a brief overview of the course. So this is a course linked to the course syllabus. And later I will post the link of the course syllabus. Sorry, this is actually multi-screen, so I need to close this one. And later in the cameras, I will post the link to the syllabus and also the course web pages. And if you want to search, you want to reach the course website or syllabus in Google, it is also very easy. So you can simply search my name in Google. And then the first item is my homepage. And see there's a section teaching, and there's a link to the course web page. So all the course content, the information, the updates regarding course will be shown on the course web page. And here is a link to the syllabus. So let us first go through the syllabus, and then jump back to some pages in the course website. Okay, so the course syllabus includes all the details, information about this course, and okay. So I'm the instructor. Also, this is time for the classes and the place, and this is my email address. Of course, you can identify my email address in the course webpage as well, and this is for link to the course webpage. And we have a two diligent teaching assistants. So his name is Yishuai Du. Yishuai, can you stand up and everybody know you? And he's a very warm-hearted and very responsive to all the questions. So if you have questions, do not hesitate to send him, bother him. It's his job. So I would rather use mouse. So, and we also have a teaching mentee, and Jimon Pan. So please can stand up. And Jimon Pan will help you in the office hour also in reading and answer the questions as well. And later we'll tell you the office hours. So, and in some time, maybe I will be, due to some emergency issues, for example, last year, I was affected by influenza, and it was very bad. And I laid on the bed for 1 month and got fever every day. So fortunately, I have a very good teacher mentee, and he helps to give some lectures. And here's our office hours. We provide abundant office hours. Actually, in every weekday we have office hours. Monday, Tuesday, Wednesday, Thursday, Friday, every day we have office hours. So if you have any questions regarding the course, such as course content, overall assignments, course projects, whatever, don't be shy. Go to the office hour. We're ready to help you. So here's the schedule for office hour. So for me, the instructor, my office hour is before each class, 3:30 to 4:30 in my office in the Merrill Engineering Building, abbreviated as a MAC. It's just beside the web building. And the TA, Yishuai, his office hour is on Tuesday and Thursday. Tuesday his hour is between 10 a.m. to 11 a.m. and Thursday is longer, from 9:30 to 11. And for our teaching mentee, Zhirong, his office hour, he provides a very long office hour, 2.5 hours on Friday, from 2:30 to 5 p.m. every Friday. So here's the basic description of our course. So the course introduces basic knowledge of machine learning. So the topics consist of several fundamental and widely used supervised learning or unsupervised learning algorithms, such as decision trees, perceptions, neural nets, kernel methods, and etc. And what is the goal of this course? After taking this course, we expect that first, you can understand machine learning ideas and paradigms in general. You have a feel about what is machine learning. And second, you should be able to identify or formulate appropriate machine learning problems from your own problems, whatever your research or applications or the problems when you are doing your job. And third, in addition to that, now you will be able to design a machine learning model and implement your machine learning algorithm and test whether it works or not.
Did you say we were going to implement unsupervised learning?
Whatever machine learning algorithms we teach in this class, you are required to implement in your homework assignments. So this is the basic idea.
Unsupervised in particular?
No, actually we will, as we will talk about this later, because we will mainly focus on supervised learning.
Okay.
This is a major topic, and if you have time, we will talk about unsupervised learning as well. So, any questions so far? Okay. So here are the books. So there are no designated books for this class, and all the lecture content will be covered in the lecture slides. And after each lecture, the lecture slides will be released in the course webpage. And later I will show where the lecture slides are uploaded. And if there are some extra materials, we'll upload it to Canvas as well as the course website for you to download. And also share the link of the lecture video. So as some of you have noticed that there is a camera here recording the lecture videos. And it's actually streamed on the YouTube data science channel. But because it's a and all the lectures are recorded in SD card, it hasn't finished, hasn't fulfilled the streaming function. But later, all those lecture videos will be uploaded online, and we'll post the link to those videos on the course webpage. So regarding books, if you want to further extend the width or the depth of this course, and here we list the 5 classical books of machine learning, and most of those books are available online. You don't need to buy them or borrow them in the level. And regarding the mathematical foundations, so let me show you how I identify my course website. That looks like. So you see, there is an information section, right? So in the information section, it contains prerequisites which are consistent with the course policies. These are all consistent with the course syllabus. And here's the textbooks. And also, we have some extra resources about mathematics part in our course, like linear algebra and probability and statistics. These are very useful, especially if you want to review your linear algebra knowledge. This is very classic, written by Comita, a graduate from MIT. And probability and statistics, if you have taken a probability class or statistics class, but you just forget the basic concepts, just take a look at the David Bly's, is our big name in machine learning. His slides about review of probability. That will be sufficient. So let us continue the syllabus. Need to move again. Please bear with me. And prerequisites. So here are the official prerequisites. Well, but what does this prerequisite tell? Is actually, we assume, to take this class, we assume you know basics of probability theory and statistics. It's very important because nearly all of machine learning models are built upon statistics and probabilities. If you don't know them, or if you're hard to know, to understand the basic concepts, it'll be hard for you to understand why the machine learning models work like that. And also, we assume you're familiar with linear algebra, especially operations of vectors, matrices, and matrix vector derivatives. This is very important because when we talk about derivation in machine learning, mathematical machine learning, we operate on vectors, matrices. We rarely operate on scalars. The reason is that during the implementation, all the machine learning implementation will use or call the mature and highly efficient linear algebra libraries, like I forgot the name, sorry. I forgot the language that's very commonly used. That's why you need to be very familiar with that. And also, you need to know, you need to have the skills in algorithmic design and programming. You're not necessary to be a programming master, but you must know how to program, how to implement your models. So after today, we'll release the first homework. This homework only contains a few mathematical problems to check your background and to force you to review those necessary knowledge. If you feel those problems are pretty easy and to solve, or if you feel I just forget some concepts, I just need to open my book, that's totally fine. But if you feel very difficult, and if you're pissed off by those problems, and honestly, I suggest you can take this class later, because it will feel very painful. You will really feel very painful. We won't teach you how to do linear algebra. We won't teach you how to do the matrix derivatives. Those are basic knowledge we assume you all know. So under this case, if you still want to do machine learning, I would suggest you to take necessary courses to enhance your background. And later, you can take machine learning class again. And nowadays we have every semester, every fall and the spring semester, we have this machine learning class. And the class content are highly in line, highly aligned. So don't feel that you will miss this chance to take this class and get some grade. It's better for you to like have enough background and then take this class. Any questions so far? Okay. And then,
Sorry, I do have a question about programming skills. Do you recommend using a specific programming language?
yeah, very good questions. Yeah, let me discuss right now, okay, rather than later. So, we'll highly suggest you to use 3 languages: MATLAB, Python, or R. Although our program assignments, right, the homework assignments, the programming part won't enforce you to use the 3 languages we suggest. But we highly recommend you to do that because they are very easy to learn, even if you have never used them. As long as you have some sense of programming, you can learn it very fast. And it's very easy to they're very easy to debug. And also, regarding those hard numerical computations, linear algebra operations, they have very convenient interface to call the mature C++ libraries. Of course, you can try to implement your learning algorithm with C++, with C, or Java, whatever you want. But that will be too time consuming, and it's actually I think it will take waste too much of time in dealing with the programming details. Unless you have enough time and you really like to do that, I would suggest you the 3 languages. And I can tell you, in both academia and industry, those 3 languages are very popular, especially when you develop some prototypes. Even in companies, if you want to develop some prototypes for some machine learning model algorithm and embed them in your product, they will always be implemented first with Python.
With regard to executing the code and like reading all the data and stuff like that, is Python faster than MATLAB? They have the same algorithm coded in MATLAB and Python.
That depends. That actually depends. And your industry, Python is more heavily used because more frequently used because you don't need to buy MATLAB license. But for me, I personally like MATLAB for best because it's really good, really elegant. I don't have money to purchase one, so sometimes I use Python. But whatever 3 languages you can choose whatever. You can choose whatever. And also you need to ensure your program can be executed on K machines. That's the platform our TA and teaching mentee grade your homework assignments. And let us talk about getting help, as we just mentioned, right? So we have plenty of office hours. And so don't be shy if you have any questions regarding course content, regarding course projects, regarding the implementation of your algorithms, just come to the office hour. And if you want to seek for help offline, you're suggested to post questions on campus. Why? Because your question might not be unique. And when our TAs or the instructor answers your question, if the question can be seen by other students or fellow students, it will be more beneficial. And also, if many of us posting and discuss on campus, we'll build up a very active learning environment that will benefit the whole class. So try to post the questions on campus. And our TAs and TMs will constantly watch the cameras and respond to you as soon as possible. But do not post potential homework answers. So answers like, how can we solve like problem 2 in homework 3 are not welcome in the cameras. And if we found such kind of questions in cameras post, we'll delete it because it breaks the fairness. Any questions regarding this point? So now, here's our tentative course topics. So basically, machine learning, the content of machine learning can be organized in different hierarchies according to different standards. And here we choose the most commonly used and the easiest to understand. So basically, we can roughly categorize machine learning models and algorithms into two types: supervised learning and unsupervised learning. So what is supervised learning? Just like batch game. I give you a set of examples and I give you the answers. And after you learn from the examples, you learn how to solve problems and provide answers. That's called supervised learning. But there's also another class of algorithm called unsupervised learning. That is, I just give you the examples. I don't give you any answers. You just learn by yourself, and you tell me what you find, what you discover. And most machine learning research efforts are put on supervised machine learning. So we will focus our main topics. Most of the course focus will on supervised machine learning. And if we still have time, we'll talk about several representative unsupervised learning algorithms. So in supervised machine learning, we'll first introduce decision trees. So someone may think decision trees is kind of grandpa, it's kind of outdated. So and the coolest algorithm should be deep neural nets, deep learning. But actually, decision trees is, I believe, it's even younger than neural nets. Neural nets is neural nets are invented about 30 years ago. And decision tree is almost at the same time, or even later. And decision trees, although it perhaps is the most simplest machine learning algorithm, but it's still very widely used. Why? Because it can provide an excellent interpretation. As we will say, decision tree is essentially a set of rules. And learning a decision tree is trying to extract a set of rules from data set automatically. So when you apply decision tree model to do the prediction task, when it fails, you know why it fails. When it works, you know why it works. That's why decision tree is so popular. So I kind of hope that in the future, we are required to design our own machine learning models and algorithms to solve the problem. The first solution that comes into our mind is decision tree, not a huge neural net. And you will see why. And after introduction of the decision tree, we'll introduce the concept of overfitting and the strategy to overcome overfitting called cross-validation. And this cross-validation is very commonly used technique to select appropriate hyperparameters in our machine learning models and algorithms. Then we'll introduce boosting and ensemble learning. So decision trees, although with very good interpretability, but the performance of decision trees are not that good in practice. So there comes out enhancing technology called boosting ensemble. So basically, how can we combine a set of weak learners, such as very short, very simple decision trees together to dramatically improve their performance? That's the boosting. Sorry. That's the idea of boosting. And it turns out this strategy works really well. And as we just mentioned, data boosting, right? When it can automatically locate human faces in a digital camera, it's just a combination of set of decision trees. Very simple, very powerful. And then we'll introduce linear regression. And actually, we categorize the prediction problems into two types. regression and classification. Regression is to predict continuous variable values, and classification is to predict discrete values. That's it. And then we'll introduce the basic linear regression model and the least mean square approach. And throughout this approach, you will know the general principle, how to write down an objective function, or in other words, loss function, for a machine learning model, and how to derive an optimization algorithm to optimize your objective function so as to learn the model. And then we'll introduce a linear classifier. Why we start with linear models? Because it is easy to analysis and easy to get theoretical guarantees. So we start with the classical perceptron algorithm and then small vector machines, and talk about the large margin classifiers, and we'll give you an intuitive explanation why large margin tends to have a better generalization ability. But I will list you the theoretical justification for that. That's related to the computational learning theory. I will just give you a sense and relates to the computational learning theory. We won't go deep in the learning theory. And then we'll introduce the probability learning framework. Although probabilistic learning is actually a very broad framework, it's actually another dimension of machine learning. But here, we only give you a concept, and we introduce some instances in probabilistic learning doing linear classifier. It corresponds to the naive Bayes classifier. And after you learn naive Bayes classifier, you can try to develop a spam filter by yourself. And logistic regression, very widely used in online advertising. And of course, linear model, including linear regression and linear classifier, won't be sufficient to deal with complex work. So we want to build out more powerful nonlinear models. So we'll introduce nonlinear classifiers after that. So we'll first introduce the simplest nonlinear classifier called nearest neighbor classifier, which can be, like I can explain to you like in 3 minutes, you will understand what is the nearest neighbor classifier. But it works really well. The shortcoming is just the computational inefficient. And then we'll introduce a particular trick called kernel tricks. The kernel trick can extend linear classifier directly to nonlinear classifier. It's a very beautiful trick. And we'll introduce the kernel perception and nonlinear SVM. And nonlinear SVM will require a smart transformation of the original SVM. The original SVM is called primal, and the nonlinear SVM is called dual form. Only in the dual form you will get to know why it is called small vectors. Where does these small vectors come from? And finally, we'll introduce deep neural nets. Of course, it's the hottest topic right now. And we'll introduce what is backpropagation. And you should be able to implement your own deep neural nets training algorithm yourself. So essentially, backpropagation is an application of chain rules. So everybody knows chain rules to the derivatives will be able to implement your own backpropagation algorithm. And if we have enough time, we'll introduce representative unsupervised learning like k-means and its various like k-median and k-methods. And we'll introduce its probabilistic version like Gaussian mixture models. And we want to spend like 1 or 2 lectures to give some practical guidance about machine learning. I'll use my own experience as a case study and to introduce some empirical suggestions. We apply machine learning techniques to address problems. And also, we plan to give some tutorials in popular machine learning libraries like TensorFlow. TensorFlow is not only for neural nets, it can be used to do a lot of things. So any question regarding the course content? Okay. Do you have any questions? Okay. No problem. So grading. So let us.
Do you have some sort of like schedule of like when you're going to talk about a specific topic? Like one day we talk about this, next day we talk about this.
The detailed schedule is not coming out, but you can expect that the topics are going through follow the order. Here, like basically we start with differentiation or feeding, and here it's kind of following this order. But we could change a little bit. That depends on the progress of our class. So the grading policy. So this is actually the most important part, but I have to roughly mention that. So okay. So basically the final grade consists of several components. So first, the homework assignments. So homework assignments will take 50%. That's really huge. Yes, so if you're performing really well, you will get a very good final grade. And we have 6 homeworks, so it's kind of a heavy load. And the homeworks will consist of 2 types of problems. One type is analytical problems. That means you need to write solutions, do some proofs, derive something, and write an understanding of your particular algorithm models. And another type of algorithms is programming assignments. So basically, you are required to implement the machine learning models we discussed in the class. And also sometimes you're required to design some extension of the model we have discussed. And you're required to answer some open questions.
We're not use random libraries, or do you want us to hand code or
You need to implement the main algorithm steps by yourself. Of course, you can call some numerical libraries doing matrix multiplication, matrix inverse. That's not necessary to implement by hand. But they cannot like ask you to implement like naive. And I know there is like a library and provide one-line function calling naive. That's not allowed. That's not.
I have some comment on the program language. Basically, on the assignment, you are not allowed to use any function from the scikit-learn. Do you know what is it? It's a machine learning library, so we are basically implementing every algorithm in the scikit library. So if you use a function from the scikit library, then every assignment will become one line of code. Okay.
So actually the plan is like this. You will be required to create a GitHub repository. So every time when your program assignment is graded, you are required to upload your implementation to the GitHub repository. So at the end of this class, you will find you have created your own machine learning library. You can choose to open source your machine learning library, or you can choose to sell them. But that's the outcome. That's the outcome of your class. So that's regarding the homework assignments. And then we need to do a course project. So the course project takes 30% of the final grade. And basically you are required to use your machine learning technologies to solve whatever problems you think is interesting and important. And you can form a team. The team has at most 2 students. You're required to create a GitHub repository to store and maintain the code, the source code, and the documentation in your project. And you need to submit 2 reports, midterm report and final report. So midterm report requires you to report to report what you have studied in doing this project, and I think it's better to. So let me just talk about draft right now, because we'll continue in the next lecture, right? So basically, the midterm report needs you to tell us what kind of preparation you have done for your cross project, and the final project you should report every details. And also you need to include a link to your GitHub repository, because we will check whether your implementation is really a project. We can never fake any experimental results or your and your conclusions. And a final exam. So there are no midterm exam, and there are no other quizzes.
So did you say that the course project is a team effort?
2, at most 2.
Okay.
Yeah. And we'll discuss in more detail next lecture.
Okay.
So don't worry. And a final exam is an open book final exam. So you can bring whatever documents and books and materials, you can print out all the slides and take them to the final exam. But you are not allowed to bring electrical devices like computers, like tablets, like cell phones. The reason is that we don't want you to post on Stack Overflow to ask questions. But in addition to that, you can bring whatever materials you want. And the final exam takes 20% of the final grade. So let us stop here. And
The Canvas course hasn't been published yet. Are you going to be?
I haven't published.
Was that?
I haven't published. I should have published.
You will be publishing it though?
I think I should have published, but let me check and check and recheck.
Thank you.
Okay. Let us continue our